Okay, I'm going to review some exponent laws with you. So first of all, let's refresh our memories on what exponents are. Exponents we use when we're representing repeated multiplication. For example, if I have 3 to the 4th, that means that I'm multiplying 3 by itself 4 times. 3 times 3 times 3 times 3. Now, we need to review some vocabulary here. So that power, a in this case, that is the exponent. And this, that whatever we're taking to the a power, that, remember, we call the base. So with 3 to the 4th, 3 is the base, and 4 is the exponent. So the first rule that you learned in Algebra 1 is multiplying with the same base. For example, something like this, x cubed times x to the 4th. Well, we can do this problem the long way or the short way. Let's look at the long way first. So x cubed means that I'm multiplying x times x because that's x cubed, and x to the 4th is another x times x times x times x, and they're all being multiplied. So I can now count how many I have that are being repeatedly multiplied, and there are 7 of them, so that means x to the 7th. The shortcut for that rule, the shortcut says we just add the exponents, 3 plus 4. So I'm getting x to the 7th when I add 3 plus 4. Next, you learned how to divide when you have the same base. So dividing with the same base, we'll do the long way first. 2 to the 4th is our example here, divided by 2 squared. So 2 to the 4th means 2 times 2 times 2 times 2, and 2 squared means 2 times 2. So I can see I have 2's in common. They're common factors, so I'm factoring them out. And when I do that, I'm left with 2 times 2, which is 4. The shortcut says that when we have like bases and we're dividing, we subtract the exponents. So I keep the base, 2, and I subtract 4 minus 2, and I get 2, and 2 squared is 4. Next, when we have an exponent on the outside of the parentheses. So we have a few examples here. Let's start with this one. The long way to do this, I would just write out 3x squared 3 times because it's being cubed. So 3x squared times 3x squared times 3x squared. Well, we know 3 times 3 times 3 is 27. And x squared times x squared, we'll use that law that we talked about a moment ago. X squared times x squared, I add the exponents, that's x to the 4th. And then I'm going to add 2 more x's on, so that's x to the 6th. So I get 27x to the 6th. The shortcut way of doing this problem, though, is by using the rule, which says I should distribute the exponents to all terms in the parentheses, meaning I'm going to distribute the exponent of 3 to the 3, and I'm going to distribute the exponent of 3 to the x squared. So 3 cubed is 27, and x squared cubed, we know to multiply the exponents. So that gives me x to the 6th. So 27x to the 6th. Either way, we do the problem. So if I use the shortcut with this example, I'm just going to distribute the 4 to the x squared and also to the y cubed. So that gives me x squared to the 4th. I'm going to multiply those exponents and get x to the 8th, and multiply the 3 and the 4 and get y to the 12th. So x to the 8th, y to the 12th is my final answer. Next, if I can scroll down here. So we have x squared over y to the 4th, and that's cubed. So again, our rule says we're going to distribute the cube, and then we're going to multiply. X 2 times 3 is x to the 6th, and 4 times 3 is y to the 12th. And these are not the same base, so I can't simplify that any further. Last, let me remind you what happens when the exponent is negative. So if the exponent is negative in the numerator, it moves down to the denominator with a positive exponent. If the exponent is negative in the denominator, it moves up to the numerator with a positive exponent. So here I have x to the negative 3rd power. Well, I know that I'm supposed to keep the exponent of -3, but we're going to make it +3, but this is already in the numerator because I can think of this as that over 1. So x to the +3 goes in the denominator, and then we just have a 1 in the numerator. So that's how we simplify x to the -3rd. So here, I'm going to move the y, because y to the -2 is in the denominator, it moves up to the numerator and becomes +2. And then that's just over 1. And I can just simply rewrite that as y squared rather than keeping it as y squared over 1. Let's look at the last example here. So we have x squared to the -2 over y cubed to the -2. So we're first going to distribute the exponent of -2, which gives us x to the -4th over y cubed to the -2, which is y to the -6th. So because I have a negative exponent in the numerator, it moves to the denominator and becomes a positive exponent, and the denominator exponent moves up to the numerator with a positive exponent, and that is our final answer.